Okay, let's do this. On the right side, you see the result of my code. I lost. Really? Okay, so I'm playing Tic-Tac-Toe against a Monte Carlo search tree computer AI. For players, this is a human-like AI that makes good decisions by playing the odds. For developers, this is a fast algorithm that doesn't need to know much about your game, which makes it easy to use. If you want a copy of this code, you can find a link in the description below. If you want to learn how this code works, I will explain that right now. So this is the Monte Carlo search tree AI. It takes the current game state, and that could be the beginning or the middle of your game. It runs multiple random simulations. It makes random moves starting from your game state. Because it makes random moves, it doesn't need to know much about your game. Each simulation is evaluated with a score. A higher score means a better outcome for the AI. From each simulation, it only remembers the first move and score. Simulation scores are accumulated by move. After the simulations are done, it returns the next move with the highest score. And now I'll go over the code itself. So first, I import the random module and the AST module. I use the AST module to convert lists to text and back. I set the current tic-tac-toe player, either an X or an O. The number of simulations is very important. More simulations equals a more intelligent AI. I define the tic-tac-toe game board. And I set the starting player. I use this function to clone the main board for simulations. I check if the board has any moves left. A move requires an open spot on the board. Now I get the next move options for the current board state and player. This variable will hold all next move options. Each dot on the board is a move option. For each dot, copy the current board state. Mark that spot for the current player. And add this move to the list of next moves. And finally, return the list of next moves. This function checks if the current player has won in the current board state. A winning move is a row of X's or O's, depending on the player. Check each row for this winning move. Check each column for this winning move. And check each diagonal for this winning move. If no winning move is found on the board, return false. This function returns the next player. And now I retrieve the best next move. This variable stores each next move. For each move, it accumulates simulation scores. Now I run the simulations. Start with a copy of the current player and current board state. This variable stores all moves made in this simulation until the end of the simulation. I retrieve the next move option for the current state. The score value starts at the highest score. For each move in the simulation, I will subtract 1 from the score, so winning in less moves provides a higher score. Make moves until there are no more moves left. Pick a random move. Add this move to the list of simulation moves. Break the simulation loop if the player has won. Otherwise, subtract 1 from the score. Get the next player and move options for that player. Then, when the simulation is done, take the first and last move from the simulation. Turn the first move into a text, so it can be stored as a key in the evaluations. If the user has won, turn the score negative. That means that the AI has lost the game. Now add the move and score to the evaluations. Now all simulations are done. For each move and score in the evaluations, remember the move with the highest score. I use the AST function to convert the move back to a game state. And finally, I return the best move out of all evaluation scores. Now I use a simple function to print the board, and another simplified function to ask the player for the next move. I print the game board, and while the board has any moves left, if the current player is the user, ask the user for a move. If the current player is the AI, request the next move. Now I print the updated game board. If the player has won, print a congratulations message. Otherwise, switch to the next player. And that's it. Now I can play Tic-Tac-Toe against a Monte Carlo search tree AI. For this simple game, the AI almost never loses. For bigger games with more decisions, the AI will be more flawed and realistic. So I will demonstrate one more time. I hope this video was useful to you. Thank you for watching.